Hello everyone. This lecture is exclusively recorded for third year BSc student of BK Birla College, Kalyan. This is mathematics class paper 1. In this lecture, we will solve example based on Gauss divergence theorem. In last lecture, we have already seen the Gauss divergence theorem, and we have even solved the problem based on Gauss divergence theorem. So in today's session, we will explore few more questions, numerical question based of Gauss divergence theorem. So the question is as follows. So let me recall the assuming that f satisfies all the hypotheses of Gauss divergence theorem. So we had triple integral over v, divergence of f is equal to surface integral of f dot ds. This was our Gauss divergence theorem. In the last lecture we have seen where V is a solid bounded in R3 and S is the surface of a V. So based on this we have verified the Gauss divergence theorem, problem based on Gauss divergence theorem. So let's have the few more example on a Gauss divergence theorem. So the question, use Gauss divergence theorem to find surface integral of f ds, and it is given that f of x comma y comma z is equal to y minus x, z minus y minus x over the surface of 0 1 cross 0 1 cross 0 1. So to find out surface integral using Gauss divergence theorem, it means that I need to evaluate the triple integral of divergence of f. Right. So if they have asked surface integral, means you need to find out triple integral of divergence f. If they ask divergence triple integral of divergence f, that means you need to find out the surface integral. So solution. Okay. So by Gauss divergence theorem, the surface integral f dot ds is same as triple integral over v divergence of f dv. Now how to find out divergence of f? Grad dot f is divergence of f. So let me find out that divergence f. It is dou by dou x of y minus x plus dou by dou y of z minus y plus dou by dou z of y minus x dv. So which is same as triple integral over v. This is minus 1. This is also minus 1. So plus 0 dv. So it is basically minus 2. So minus 2 triple integral over v dv. And we have a cube. So that is very clear that we will have the limits also. It's very clearly the limits are 0 1 0 1 0 1. So that I need to find out minus 2 0 1 0 1 0 1 dv. So dz dx dy, this order now is anyway all limits are same. So minus 2, z limit is 1. If I integrate, this also will come. So finally I will get minus 2 as the answer. That is fine, that's absolutely correct. So of course one may check the verification also. It is not asked in examination or maybe in this problem, but you can always find out. This upper is z is equal to 1, this down is z is equal to 0, this one is y equal to 1, this one is y is equal to 0. This one is x is equal to 1. The backup is by x is equal to 0. So there are 6 surfaces, and uh, so you need to find out 6 surfaces, and if you add it you should get -2. So this, I think that such kind of questions is already there in your tutorial practical booklet, so wherein you can easily verify the Gauss divergence theorem. So question number 2 here, find volume of cylinder x square plus y square is equal to 1, z is between 0 to 1, using Gauss divergence theorem. Here f of x comma y comma z is given to be x by 3 I plus y by 3 j plus z by 3 k. Okay, so volume of a cylinder, or maybe they have asked us to find out the volume of cylinder. That means let's volume of a cylinder is basically that's triple integral over v 1 times dv. Okay, but if I calculate divergence of f, so what is divergence of f? Divergence of f is dou by dou x of x by 3 plus dou by dou y of y by 3 plus dou by dou z of z by 3. So 1 by 3 plus 1 by 3 plus 1 by 3. So this is 1. So 1 is equal to divergence f. So this is equivalent to saying that triple integral over v divergence of f dv, because 1 is same as divergence f. And what is divergence f? As per the Stokes theorem, it is f dot ds. So I need to find out the surface integral of f using the Gauss divergence theorem. So now what is v? Let me draw this v. It is mentioned as the cylinder with this. Now this v must be closed. So v has three surfaces, one should say. One is the round of the cylinder, and the second one is the base, and this is a top, and this is base. So these are the three surfaces S has. Okay, so we should know this. So let me name this as S1, this has S2, this has S3. So what I'll do, I'll give the hint for the S1, S2, S3, and then you can do at home. So your calculation. So this is equivalent to S1F ds plus S2F ds plus surface integral S3F ds. So calculation for S1. So what will be the alpha? So it's a base is z is equal to 0 basically here. Here z is equal to 1, and on this round part x square plus y square is equal to 1. So z is equal to 0. This means I can have the parameterization alpha x comma y as x comma y, and z is 0, where your x square plus y square is less than equal to 1 and 0. So you can have the this way. So projection here, basically t will be set of all x comma y such that x square plus y square is equal to 1. So this is one way, or you may take polar transformation. So here radius is not fixed, so it is r theta, and you may take r cos theta, r sin theta, and z is anyway 0, right? So this is what the surface of the parameterization. Then if you calculate this, then the parameterize with respect to over the surface S1, your answer to this is basically it will give you 0. So one should take the all the parameterization all in a proper way. So it is 0. Similarly, let me go for the surface S2. Now for surface S2, so that's a round part of the cylinder. So alpha r comma theta I can use. No, r is now on the round part. You can see that the radius is constant. So here the my radius is constant. Only z is moving and theta is moving. So it is theta comma z. So it is r cos theta. So 1 cos theta, 1 sin theta, and z is z. Now here theta between 0 to 2 pi and z between 0 to 1. It is mentioned. So again, if you solve it for the surface S2, then what answer you will get? So S2 f dot ds is equal to 2 pi by 3. You can check out that. And now for surface S3, how it will go for the surface S3? It is the alpha, because for surface S3 that upper part, the topmost part, that is z is equal to 1. So similar to x, so x comma y comma, that is x comma y and 1, and you can say that what is t is a set of all x comma y such that x square plus y square less than equal to 1, greater than equal to 0. This is one way of parameterization, or you can use straight away the cylindrical transformation to get the parameterization. So what is it? Alpha r uh, uh, r it will be theta comma z is cos theta sin theta and z is 1. So this way also uh, no, z is not 1 because you are moving going that round part, z is z. So your theta is between 0 to 2 pi and z is between 0 to 1. Okay, so this surface S3 will give you integral value S3 f dot ds, that will give you answer pi by 3. So final answer is you have to club this all surface integral f ds is equal to 2 2 pi by 3 plus pi by 3 plus 0. So it is pi basically, right? So one can even verify, but in question it is asked only to find out the uh, volume using the Gauss divergence theorem. That means we have calculated the surface integral. Triple integration, in fact, that will be very simple. The interested candidate who wish to verify this can do in the following way. So it's optional. You can always think of this triple integral over v, that theta will goes from uh, z is from 0 to 1, theta is from 0 to 2 pi, and r is from 0 to 1. And if you are using the cylindrical transformation, then it is divergence of f. So divergence f is anyway it is 1. So but if you are using cylindrical, so r dr d theta dz. If you solve this, I am sure that you should get 2 pi as an answer. That is an optional, you can cross check. So this basically I have calculated the volume integral. Now let me have the another example, that is example number 3. Use Gauss divergence theorem to find surface integral where f of x comma y comma z is equal to 6x square plus 2xy comma 2y plus x square z comma 4x square y cube over x square plus y square equal to 4 and z between 0 to 4. Let me go for the solution. Since it is asked to find out the surface integral, that means I need to find out a triple integral. For triple integral, I need to know the divergence f. So let me calculate divergence of f. It is 6x square means 12x plus 2y plus 2 plus 0. So it is 14 plus 2y. This is what my divergence f is. I hope I am okay. I have done clearly. So 12x I should write here. 12x. So it won't be get added then. 12x plus 2y plus 2. Okay. I need to find out triple integral. Let me draw the region. X square plus y square is equal to 4. So x square plus y square is equal to 4. And what else is given? 0 z is between 0 to z is between, I think it is 1. Let me cross check. Yeah, no, it is 4 only. Z is also 4. Z is equal to 0 to 4. So if I go for the cylindrical transformation, then any vertical line starts from 0 and it ends on the 4 only. So my z range is 0 to 4, and if I project this, then projection will be a nice disk whose radius is 2. X square plus y square less than or equal to 4. Okay, so let me see this triple integral. So yeah, I need to find out triple integral 12x plus 2y plus 2. So surface integral over S f ds is equal to triple integral over v divergence of f dv by Gauss divergence theorem. Okay, so here now I know what is z, what is so if I'm using polar transformation, cylindrical transformation, then z is 0 to 4, x is r cos theta, y is r sin theta, and r will be from 0 to 2 and theta will be from 0 to 2 pi. So it is 0 to 2 pi, 0 to 2, 0 to 1. Divergence f is anyway 1. So it is dz dy dx. Okay, it should be dz d r I should write, and this is d theta. Right, please, cylindrical transformation I'm using. So dr. Okay, so this is equal to, so if I do this all calculation, then I think we should get 32 pi. So that you can cross check, you can do at home, that is not difficult part. Okay, so let me take one more example. So far we have done with the 3 examples. So the question number 4. So find surface integral f ds using Gauss divergence theorem, and f is given to be x cube comma y cube comma z cube over x square plus y square equal to 9, and z is equal to between 0 to 2. This problem is similar to what we had in a previous class. So one need to find out divergence of f. It is 3x square plus 3y square plus 3z square. So 3 times x square plus y square plus z square. Okay, but then 3 times x square plus y square is r square and it is z square. So if I use polar transformation, x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. Then let me find out the triple integration. How does it goes? It is first we are taking, we'll have a this is divergence of f, triple integral over v dv. This is equal to, so let me write down this. Theta is 0 to 2 pi, and then r is 0 to 2 and z is 0 to 2. So is it 0 to 2 or something? 0 to 9 है, so 9 है तो मतलब x square plus y square is equal to 9, so it will be 0 to 3. Okay, and then here it is divergence f have we calculated. It is 3r square plus z square, and the order of integration is dz d r and d theta. So if you solve this, you will get 32 pi as answer. Okay, so there are many more example based on it that we can do actually in a class. So timing this much is enough. So even this problem can be solved with the verification. There will be three surfaces, z is equal to 0, z is equal to 2, and z is equal to 9. So that way also it is possible. So thank you so much for attending the lecture.